ladies and gentlemen, does anybody wonder why this green transition is taking so long, so much time, and how we could make it faster? If you do, then you are at the right place, because here we have some guests who are going to highlight the issues on how to make this green transition faster. So, first of all, we know that this green transition actually has a great potential, first to clean the environment, then second, to create clean, cheap energy. And with this clean, cheap energy, can you imagine how much economic growth you can do? You turn poverty into abundance. And not only that, it can also contribute to global peace. You know, there are some countries that are using oil revenues to fund wars. And if this oil price drops below 40 or even below 30, these wars stop immediately. And that's why, under the auspices of United Nations Assembly proclamation on International Decade of Sciences for Sustainable Development, which was achieved with efforts by our good friends, previous Vice President Nebojša Nešković, under this Earth Humanity Coalition, we have this joint effort of World Academy, European Academy, and Alma Mater, It's About People conference, which I am very happy to open this vast talk as a moderator here. First, let me present our dear keynote speakers. Next to me is Yuri Gogotsi. He is professor from Drexel University, and if several 100,000 citations and the H-index, I think well over 200 is not impressive enough, Yuri is also a very dedicated person to the advancement of society and to world peace. And he has some good ideas which he's going to share with us today. But not to continue, we have other guests as well. So online, we have Professor Eva Kovačević, who is professor at Université d'Orléans and at GREMI. Welcome.
Thank you.
And the other guy, thank you. The next guest is Professor Alexander Nominet, who is professor at Université de Lorraine. And he has a lot of interesting titles. He is leading the Erasmus Mundus Green AMA study program, which is a wonderful success. And in addition, he is also one of the researchers of our newly established Global Peace Offensive Center here in Maribor. And last but not
everyone.
Hello, Alex.
For introduction.
Thank you. And last but not least, to my right is sitting Uroš Cvelbar, who is actually a co-organizer of this event. He is the one who selected the guests. He selected the title of this event. And also, he suggested this format that we only have some guideline questions at the background, and we talk about what we can do to really improve this world. And with this introduction, I would... there are actually just a few things I wanted to show before we start. There are a few points. We talk about the green transition for a long time, and yet only a few % of global energy comes from green sources. Over 75% comes from fossil fuels, which means that something is not good. And also, these fossil fuels actually determine the price of energy, which means that when something bad happens, the price of energy goes up, and all the society suffers because of that. Prices go up, food price goes up, and people can afford less, and those people who are selling the oil can afford more ammunition for their wars. Which means that something obviously needs to be done to bring this price of energy down, and that's why it's my great pleasure to invite our first panelist, our dear friend, Professor Yuri Gogotsi, to tell us about the most promising opportunities from your research field in the last few years.
Thank you very much, Alexander. I'm a material scientist, and naturally, I'm going to talk about materials, because pretty much progress of humanity over thousands of years was determined by progress in materials. Moving from Stone Age to Bronze Age, Iron Age, and currently we're living in a Silicon Age, really defined what becomes possible to us. And if you want to truly move to the era of green technologies, green energy. And under green energy, since I'm the first one presenting, we probably need to define it here. We understand energy produced from renewable sources or sources that don't contaminate environment. Same way, green technologies are technologies that don't negatively affect the environment. And as you have already heard, first of all, we should stop burning oil, gas, coal, and switch to new sources of energy. And here again, materials have played a key role. One of probably the first visible to everyone technologies is solar. Solar cells are everywhere. In Slovenia, taking a train from Vienna, crossing Austria and Slovenia, I saw solar on roofs on many buildings. And most of the cells are silicon-based solar cells. Silicon is the same material that enabled all electronics we use nowadays. Now it's also in solar cells. And last year, for the first time, the price of solar energy became actually lower compared to energy produced from any other sources, less expensive than burning coal, less expensive than nuclear energy. And this is an enormous factor showing that green technology can really be groundbreaking. And what it also enables right away, many other effects. For example, agrivoltaic, new field emerged. We can now grow crops in shadow of solar batteries, powered by solar batteries. And this again opens opportunities in agriculture, which is also one of major consumer of energy. And if this is not enough, we need to think about how we make this solar cells wearable, penetrating further field. But there are also challenges emerging. Energy storage. We need batteries, we need supercapacitors. And what is very important, that actually even in batteries, silicon, the same material that again enabled our electronics and to large extent solar energy, plays a role. Silicon is replacing graphite anodes in the new generation of lithium-ion batteries. So I think this is how the development grows here. And if I'm allowed another minute or two, I would also like to mention that we're still using largely at the moment materials we have developed over the past decades. But totally new opportunities may be opened by new materials. Again, breakthroughs, because clearly doesn't matter for how long we would improve lamps, we would never have electronics that was enabled by semiconductors using traditional technology. Same way, there are certain things that we cannot make using current materials. And for example, in my laboratory with colleagues and students, we developed 15 years ago a new family of materials which we called MXenes. They are two-dimensional sheets like graphene, but with very unusual properties. For example, very thinner than human hair film of MXene has very low thermal conductivity, preventing heat from being lost or penetrating from outside. As a result, with a 10 times thinner than human hair film, we can make very warm clothes. Or imagine spraying film of this material on walls of every building, decreasing consumption of energy. And 30% of all energy in the world is used by buildings, commercial and buildings where we live, and about 1/3 of it is used for heating and air conditioning. Imagine cutting just by a few percent those energy losses or energy that we need to generate to heat our buildings or keep us warm here. So again, Whenever we select a target, we need to go after something that will make a very big difference. And there are a lot of efforts that go into, for example, something I don't personally believe in, like capturing carbon dioxide is a good idea. But if you transform it to fuels, you basically just prolong the use of oil and coal and gas. While by using new technologies, we can really eliminate and by this make obsolete much of the fuels and use resources of the Earth's hydrocarbons, coal, for making new materials that will help us solve the problems here. So again, the message at the end I want to leave you with is that we need creative use of existing materials, and we need to discover, develop, and manufacture new materials which will allow us to build new green technologies, environmentally friendly energy generation, storage, and technologies that will minimize energy consumption and allow us energy storage here. So I'm going to stop here and let other panel members to take from there.
Thank you for this wonderful introductory statement and a lot of interesting thoughts and ideas. And as we were talking about materials, I think with us we have Professor Alexander Nominet, who is also an expert in how to find and improve the use of those rare materials that are necessary for the green transition. Maybe you could elaborate from your point of view.
Thank you, Alexander, and thank you for this brilliant introduction. I think it's important to mention at this stage that from that is very much needed from the fossil to the renewable energy, that there is a huge need in materials. So we will need more materials and more different ones. So for example, we speak about silicon, as Professor Vygotsky will just mentioned. The fact we have in our phone several kinds of different materials, elements that we're talking about, but there is also some medium and other materials.
Okay. Yeah. Alex, I think if you turn off your video, your voice is not going very clear. Maybe your voice will get better if you turn off the video.
Okay.
Thank you.
Sorry, is it better than now?
Okay, please, yeah.
Sorry for that. So I think we will need from the fossil to the renewable, we need extremely high amount of materials, and the question is how do we choose them? How do we choose them? How do we fabricate them, and where they are, and in which countries? So this is the real challenge that we will have to face. And I mention on top of what Professor was mentioning and what you, Alexander, was mentioning at the beginning, especially the transition. I'm really also by saying that this is electrification of society. And for example, the quantity of copper that can be needed to do this transition is huge. And now we are how much material copper in purchase than in the whole history of the world. Yeah, it's that. I'm afraid
it seems like your sound is very poor. Yeah. Yeah, I'm sorry. Thank you first for this introduction. And it seems like your sound is very poor. Perhaps we move on now to Professor Eva Kovačević, and you would come back later when your sound gets better, if you're okay.
Okay.
Yeah, thank you.
Thank you. I'm sorry for Alexander. I hope you can hear me.
Clear.
Is it
yes.
functioning now?
Yes,
okay.
Excellent.
I feel better now. So it was really interesting to listen to you, and also the idea of the whole meeting is very interesting. I was just participating in some others because I turned around, and it was very interesting to see new Renaissance discussion that kind of gave me a base for the thinking today. I will change a little bit what I prepared, because we are talking here not only about technology, we are talking about conscious that should be there on a little bit more global level. So in one way, there is my research field, and then there is the global consciousness about the green technology and implementation in the industry. And also we live in the wake of very strange times, very hard times. We had these hard times before, but now with several wars and geopolitical situation, everything changes in our proper research fields. So if I'm talking about my research field, I'm working at the university, so I'm involved in different courses concerning also energy conversion. And my research is one CNRS Institute. So from my field of view, from my field of research and my point of view, my field is plasma or laser. So how to make a better process, how to make a green process. And plasma is here one very logical idea, because already we are talking a lot about fusion, and this was also one part of our work. Fusion is here a very important thing to mention. And we have to speak about critical materials, critical processes, and critical also synthesis, chemical synthesis. So I think one of the things that is important is synergy and multidisciplinarity that we need to go on. Because as Alexander mentioned, critical materials, this is something that is needed. And I think from my research field, plasma-assisted gas conversion, plasma-assisted production of many materials that Yuri also mentioned, is one thing that is very important. It's very hard to say or to predict several things, because our work is also now inflicted by several crises, by the prices of gases, by the availability of materials. So our thing is also to think on the future and dual applications, where we have to think about reactor scale up, energy efficiency of every process, where we have to think about different coordination on international level. So in my field, for example, what we do, on one hand, we think about processes, how to make a design of the process, of the plasma process, that it can go to the industry, and to look at the same time at the fundamental research. We are looking for European networks that can help us in the research, and also there is something that we are implementing everywhere in European and especially French institutes, is the groups that are looking at the green technology implementation within the institute, so that your research starts to be green and produces the green. So to take the look at the whole cycle of life of your process and your productions. This is one way that we can address the things. And of course, thinking about materials that are harsh conditions, elimination of any toxic byproducts. This is something that where plasmas came in the game. And I think my field is in moment really developing a lot of different products, a lot of different solutions concerning the batteries, concerning the future sources, concerning also different type of complex or different nuclear reactors for fusion. There are a lot of things that are now really exciting in our field. But we have to be at the same time also realistic.
Exactly. Many thanks, dear Eva, for this really nice overview of lots of different ideas, the applications of plasma. You also mentioned fusion. You mentioned that there are hard times. Hard times are there so that we raise kids that are going to be strong and good people. So everything has its purpose and meaning. I believe that now we are at the point where at the World Academy we decided to do this so-called global peace offensive, which means to do whatever is necessary to bring peace. And in science, what we can do is to produce better knowledge that can enable better technologies, so that the price of energy goes down and we can make our share. And here, our fourth panelist, Professor Uroš Sveber, he is also the fellow of World Academy and of European Academy, member of the Club of Rome. And a few years ago, actually, with Uroš, we were actually at the Club of Rome meeting in Rome, and we were walking down the streets of the Eternal City, and we had some discussions where we actually brainstormed some great ideas. We thought that we are extremely optimistic, but now we think that we are actually maybe too modest. So maybe you can share your view of where we stand.
Yeah, I think that thank you very much. I think that the joint nominator, as we've been speaking, is actually energy. And I think this is also, partially part of my field of research, is this kind of how we can actually get more energy, how we can actually do the processes in a better way. So, for example, low temperature electrified chemistry is one of the ways how we can do it. So this is also a joint nominator, I think, from the previous speakers when Yuri was speaking. So we need nanostructure catalysts, we need new materials, we need plasma processes which can add the value and actually turn the renewable energy into either fuels, fertilizer, or any high value materials, which can reduce, so we reduce the waste, we reduce the carbon footprint. And this is the only way how we can actually target what this International Energy Agency is looking for, and they're looking for 4,600 gigawatts of renewable energy every year, which we need to supply, and that's the only way, I think, forward in this respect.
Exactly.
Yeah.
Thank you very much. So after this initial round, we actually made quite a good progress. So now we have a review of what can be done, how science can contribute, and now we can move on to the second question. And the second question is actually related to, okay, we'll go to this one, related to peace. We had yesterday nice roundtables. One was on global peace offensive, and we have been working on this for years. In recent years, we know that the situation in the world is not ideal. There are too many wars that would need to stop. Our dear friend and honorary president, Ivo Šlaus, actually made an appeal 2 years ago. He said, stop all wars now. And people just don't want to listen. And now the question is, how can science, what you are doing in your field, how can it contribute towards peace, to making these wars stop one way or another, either by dropping the price of oil, or maybe you find some better method? Professor Yuri Gogotsi.
Oh, well, that's really a difficult but very important question. As you have already heard, energy is really key to pretty much all technologies. Late Richard Smalley, Nobel Prize winner who discovered fullerenes, listed in his speech more than 20 years ago all the basically most important problem for humankind. And energy was on the first place. And the reason is, if we have enough energy, we can solve other problems. We can provide drinking water, we can grow food, we can take care of many other issues. If we don't have energy, there is war for scarce resources. Some countries that have enough energy, oil and gas, will use this energy to either oppress other countries, push their agenda, or fuel war, like you can see in the case of Putin's Russia nowadays. I've been working for 30 years in the United States, living in the US, and I've heard a joke that America goes to fight for freedoms to various places, but wherever they go, surprisingly, they find oil. And the reason for this joke, of course, is the sad reason is that oil is a very important resource, has been over the past century. And as a result, control of oil allows countries to fuel their economy, but also is the reason for many wars happening in the world. So I think the best way of this is democratize the energy. And one way of this democratization is delocalizing this energy. I gave an example of solar. Imagine having solar batteries on the roof of every building everywhere in the world, and it's very doable. Look at the speed, for example, China is putting solar energy nowadays in a number of countries as well. Imagine electric cars in a garage that can stabilize this grid and also be charged from solar. It will minimize load on the grid and maybe actually avoid even building large grid in countries which are less developed. And we have very good examples. Cell phones came to Africa where no landlines were available. It just was cell phone technology that came, allows communication, led to much faster development of many countries, brought internet. Very similar way, we need to bring decentralized energy harvesting. It can be solar, it can be wind, it can be water, depending on resources available. And similar way, energy storage. And I think this will, to a very large extent, decrease this fight for oil and enable many more countries become less dependent on few producers of energy, what we observe nowadays. So I think those green technologies will help us to move to more peaceful future.
Thank you very much. Let's hope this is true. And now I think we can move back to Zoom and we can try with Professor Nomine the voice if it got any better.
I can hear you well. I'm just wondering.
Okay, let's try. We are looking forward to hearing your ideas. I'm not sure. Maybe your microphones in the ear are not well, or if you try something else.
Change the microphone to.
That's fine. Okay, it seems that it's fine now. Let's try. Yeah.
Oh, okay. Sorry.
Better than before.
Hey, well, sorry. I'd like to share a personal experience similar to that from example, what you were saying. I think that's I can say. Well, the teacher, called triggers, we did support it that way. But from the teenager, it was strange to see the commodity in subject for the war. And to motivate him to do just is that it really localized energy, and also use and show the abundant. Because we can localize the energy, but some energy comes. So needs to be abundant. And
Alex, I think we have a problem again. Do you think you could connect from your phone maybe instead of you would get a better connection? Maybe you try to do it from your phone. Yeah, you try to connect from the phone. And in the meantime, we would ask Professor Eva Kovacevic for the opinion of what can be done by science to foster peace.
I agree very much with what Yuri said. Energy is a chip in the power game, and it's very important to control the energy production and especially strategic materials and critical materials to be sovereign in these aspects, and maybe use this chip in a positive way to influence the politics in the direction that is different than a war. I have one behind me, and it was not nice, to say it mildly. And the science offers us something very specific. Science has a unique capacity to create common ground. No country, no city can evolve alone in science and not in the energy. So I will not go in details which subject is the best. For me, it's definitively anything that is concerning gas conversion, energy production, clearing water, everything that Yuri already said. but we need shared solution for global stability. We need mutual shared infrastructures. We need even more fair data. This is hard, especially seeing the European policy that is necessary on dual use. So this involves also security of the data, which leads also to certain instabilities in development of technologies. If we look what we need, renewable energy, sustainable materials, but also really reconsider things that are cooperations, because as said, there is no country, there is no researcher that can bring the revolution alone. And we saw even during the Cold War, we saw development in the propulsion that we feel today in the space science. It was the game between tokamak and stellarator, for example, in the fusion. It was the game between two types of the jet propulsors a long time ago. So I hope we can go back to this situation where we can collaborate, where we can have shared institutions, and with one strong Europe, with strong exchange also within the Europe, where we can provide also for the peace globally. So this is my 5 cents for the game.
Thank you for sharing. It's really important that this cooperation, like ITER, is an example where we do fusion together, all nations all over the globe. And now
what doesn't function in the moment. This is also one thing that you see. This is one eclatant example of all the wars that we have. All the problems that you have on the global level, you can see by looking at ITER project. We are missing cooling parts from Russia. We are missing magnets and some other things from Pakistan, Indian region. So if you look at the global politics, you see reflected in ITER. On the other hand, development of materials from ITER are something, or plasma development of different materials is something that can solve the situation maybe for other energy crises. But it's thank you for this example. This is really illustration of what is going on.
So there is a challenge. I mean, there is a challenge in ITER, but whatever they do, I mean, other companies like Proxima Fusion and people from MIT and other people who are doing fusion projects can actually take advantage of, because they need materials.
Yes.
And,
yes, but we have also Renaissance European, and we have Gauss. It's also European, and that are really excellent private, based on academia, that are specially taught to address the global crisis also today, to connect, to reconnect us.
Exactly. Also, Proxima Fusion. I mean, in German, there is Proxima Fusion who is using the Wendelstein concept, and they are doing very good job. So hopefully, I mean, somebody really does something useful in the next years. Maybe now we have Professor Uroš Svelbar, if you could add something to this.
Actually, to follow up on this, it has been shown in the past that actually science reduces polarization, especially when we have a joint goal, aim, or a problem which we need to solve. And no country by itself can solve it. So, and this is a classical example, is large infrastructure, institutional evidence, or any other benefits. We have, for example, a project called Sesame Cyclotron, which has been, jointly built and run by Egypt, Palestinian authorities, Israel, Turkey, Iran. And if we can join around this kind of infrastructure problems or solving problems, then we can. I think science can solve this problem.
Exactly.
Montreal Protocol is one of the examples.
Exactly.
To when we merge around the infrastructure, which can become a global, universal, and can solve humanity's problem, and this is what actually WAS stands for, and it's one of the major aims, and WAS has been participating in such activities.
That's right. Yeah. That's right. I see that Professor Nomine is back with us. I think your connection is better now. So you can try to continue with your statement.
Do you hear me well now? I mean, is it working better? Because I changed the microphone, I changed the phone, I changed the connection, I changed everything I could change. Is it working now?
There is some noise in the background.
Okay, I can just try to go out. It's gonna be better. It's better now.
Okay, now it's better. Yes. So maybe you add a few sentences to what now we heard from professors, and yeah.
Yes, absolutely. Yeah, I say that the choice of the materials we use is really important. And as a scientist, we cannot ignore it. We cannot live in our ivory tower, simply thinking that we make discovery and we don't try to imagine that they have an impact on the geopolitics. Um, it takes time, but the materials that we are inventing, um, discovering, or the use we are inventing of those materials is generating needs, and the needs generates the geopolitics of commodity. And we understand very well that they can have potentially sometimes very dramatic issues. So I think what we do in our research is to try to discover materials not only driven by the performance, but also driven by the abundance of the materials and the abundance and also the supply concentration. We try to find materials that are not concentrated in terms of their supply, so that they do not become a subject of conflict, or at least they have a smaller chance to become a subject of conflict. This is a hard task in the sense that it changes drastically our approach to the discovery of materials, putting a little less importance on the performance and a higher importance on the availability. So it's not necessarily a method that is easy to transmit right now, but also this is full of opportunities because not many people know that actually the number, if you just make a simple calculation of mathematics, the number of possible alloys, the mix of metals, if you prefer, is actually bigger than the number of stars in the universe. So it's an absolutely huge quest to find them. And well, if you think about what NASA is doing when they are looking for a new planet, they don't look randomly. They look with some reasons, with some rationale to just try to find as soon as possible the right candidate. So basically, this is what we are doing. So, well, this takes time. It doesn't provide very rapidly, instantly a solution. But the day when materials is failing for geopolitics, we'll be happy to have a substitute that's ready on shelf. And this is not science fiction because if you remember a few months ago, Donald Trump was sanctioning China, he's threatening to sanction China. And the response of China was to ban the, um, the export of gallium and germanium. So the production of germanium is a few tens or hundreds of tons. It's a very small amount, but that was enough to have a huge impact on the policy making. So the Trump's plan got defeated by a few hundreds of tons of very rare materials, which is germanium, and maybe a few thousands of gallium that is in every of your phones and every of your screens. So you understand the impact that very small amount of materials can have in the world's governance. And behind those materials, basically, they are scientists. And it's people like us, I mean, that basically had the idea to use this germanium for that purpose, or the gallium for this other purpose. It's not just something that happens incidentally. And we came to those materials because we were looking for the performance only, performance in cost, right? We try to optimize this ratio of performance and cost, not necessarily taking into account the question of the availability and supply chain risk. So this is what we try to solve, and it could have implications that are much broader than what we think. So it means that basically countries may have different needs, and they may want to develop much different materials based also on their geopolitical choices. And that means that actually it would go against 50 to, well, actually more than 50 years, more than a century of development of the standardization. So we decrease the cost by standardizing, by having a solution for as many people as possible. So in that case, it would mean that, well, the good solution for China would be a good different than the good solution for USA, which would be different than the good solution for South Africa or from Saudi Arabia, etc. So it goes much beyond the simple case of the physics, the discovery of new material. I hope my point was more hearable this time.
Thank you, dear Alex. Yes, this was a very important point, and we are glad that your voice is better. Especially this point that you can make huge impact with very small quantities of materials. Because for the next round, we have a question: what would be the technology that can make the biggest impact with the least amount of effort to produce really some significant impact to society? And perhaps we start again with Professor Yuri Gogotsi. What is the technology that can have really the biggest impact if we invested it now in the next 3 to 5 years for our society?
First, I would like to build on what Alex just said. History shows that real breakthrough and major shifts in technology happen when material innovation was accompanied by manufacturing, by production, and production was possible because of availability.
Yes.
If germanium, which was the first material used for transistors, remained the material of transistors, we would not have such a widely spread, widely used electronics. Silicon, which is available pretty much everywhere in the world, made a difference. There is another negative example. For example, there is a very nice, potentially very useful technology of thermoelectrics, materials that can transform heat into electrical energy. We would be able to harvest a lot of heat, waste heat, but the key material which is needed that shows best performance is are metal tellurides. There are several. And tellurium is as rare as platinum. As a result, this technology, which is potentially useful, has not been able to make a really major impact on or affect the energy landscape significantly beyond electronic devices, something else. So I think what is important to really make an impact, we need to think what materials we developed can really be game changers. Silicon, carbon, nitrogen, titanium, aluminum are available everywhere pretty much in the world. Yes, they are abundant elements. And whenever you have materials built of abundant elements, it's largely economy of scale. We have these white ceilings and walls in this room painted by titanium, which is produced several million tons per year just in China alone because it's abundant available. So I gave an example of titanium carbide MXene, where similarly painting walls, we can potentially significantly decrease heat losses and prevent also heating by infrared energy coming from sunshine on a hot day in Slovenian summer. Those type of technologies, not necessarily producing more energy, but minimizing the need for energy by better thermal insulation would be very important. In America, for example, we have very poorly insulated houses. As a result, we consume per person on average twice the amount of energy our houses compared to European building things here. And I think this is where we need to look at the entire energy landscape and balancing these processes, not only making more energy, but storing energy, wasting less energy. This is what will bring immediate results in the next few years. And then I hope very much thermonuclear energy and other major new energy sources may kick in that were discussed by my colleagues earlier today.
Exactly. Thank you very much. This is really a very important point, both on materials and also on thermonuclear fusion reactors, which are coming hopefully soon. And now, as we are talking about material, I think we should go back to Professor Alex Nominet to add your points following this, what we heard from Yuri now.
Yeah. Well, I can only agree with what Yuri was saying, that the abundance has to be taken into account. And yes, that's the easiest things. I mean, not easiest, but probably the simplest things to do is, and where the World Academy of Science has a moral power to have an impact on the society. Because Yuri, you know, I mean, when I propose this type of ideas to do some light emitters with abundant material, they say, "What for?" And the people, this is the sad part of the sad destiny of the human being, not to see the storm coming when the weather is shining. Why to basically change the existing materials if we have something that works? This something you learn in the engineering program. If it works, don't fix it. And we are really much in that situation that many things works, therefore we don't want to fix it. So we see that these materials they have already been, and they will be used to basically in the conflict, either to justify conflicts, either just to have conflictuality. So the thing I think is important is really that the massively that the use of abundant materials, or at least to scale the need that is targeted with the resources, should be a must for every. It should be a good practice of every scientist, right? I mean, I will not name the people, but I would say I found some research, for example, on the batteries that was based on extremely rare materials, and this is a lot of public funding, right? So it's nice, but basically, eventually, it will have no application because we will run out of these materials in 2 months. So this should become a good practice, and I really believe that the World Academy of Science can do a lot of things on that.
Line also Professor Eva Kovacevic. If you could add something. Yes, we hear. Your microphone is muted. Yes, now we hear you.
If I look at this meeting and the VAS and the European Academy, there is a really interesting ground to make networks to connect people. And if I look into my specific field, we were talking about thermonuclear parts, but we are talking about something else. Plasmas are gas discharges that are relatively efficient in creating the material, in synthesis of material, and can be connected also to batteries, to many other means how to produce materials for the energy. And one of the actions now that we're observing in European Union are also the initiatives by European Commission concerning processes and critical materials. So I expect that this initiative, I am for EU, will give something big in this field and will connect us, European Union or not, in a larger network that will work together on different types of work, specifically those parts that need that already we have already several pilot units in several countries on different type of energy production, on production of materials. This is, I think, something that needs also financing, because in finding the solution, we need also financing. We live for certain money, so we can be idealistic, we can ignore many things, but finally, we also need to eat. And one thing is we need different type of fundings in the moment for different type of activities. One of the things that is coming is also, that is really important, is to connect better with the industry and to raise the awareness about the different technologies, different things that we were talking now with the younger generations. So this is something also that should be transmitted, because finally what we are discussing now here, it's something that goes as a burden of this next generation, our students. So I would then go for platforms and pilots that are there for gas conversion, for conversion, relatively efficient conversion to different materials that are important as ersatz, as a replacement for critical materials, especially development of new batteries, development of new technologies, and of course this conscious that can bring breakthrough, it's consciousness that we can create by new generation.
Thanks. So many great ideas so far. We still have Professor Uroš Svelber. So what do you think would be like really the best thing that we can do in the next 3 to 5 years to make a breakthrough and also to attract the best and the brightest students to those breakthroughs?
Yeah, my opinion actually is that, the breakthroughs comes suddenly. So I'm more in a favor. We need to secure the future. So I think that actually this is a step process. What we need to utilize is actually scale up the existing technologies, which can already, at least make a base when we initiate new, for example, already budget crossing technologies which can be implemented. We have solar energy, we have PVs, we have batteries, we have industry electrification. Only solar already composes 80% of all renewable energy which we are making.
Exactly.
But the batteries and the others, for example, I have here information that the battery demand has already passed 1 terawatt per hour. The EV battery packs prices also fell below $100 per
Yes.
kilowatt hour
Exactly.
in 2024. So this is
Yes.
2 years back. So we are in a good transition, and this can be a form base on which we can actually then make fusion, first feasible and then, electrically efficient in terms of. So this is a gradual process, and we have a
Yes.
lot of competing technologies at the same time. Even hydrogen production, which might, with the scaling and crossing this cost boundary, can be, a good platform or base on which we can build in order to facilitate this kind of green transition. I don't think there will be sudden impact, because it always requires capital, funding, research. But we are steadily growing and building the base for this kind of a transition. So I think that actually everything, at least in perspective of 5 years, it will happen gradually in steps. Some steps will be larger, as we see, or as we saw it in the previous decade with solar, but we can expect more on energy, new materials. It all takes time. An average transition from technologies into real practice is 5 to 10 years minimum. People are thinking that when we come up with something that's going to be next year. No, it's
Exactly.
a transition period which can be 15 years. So I see this as a gradual process all overall.
Exactly, very important. I mean, it's very important view also for the public, to understand that in science you don't make success tomorrow, but it takes time. And also, I mean, we say, let all the flowers blossom, and those that will be the best will grow the farthest and make the best contribution. And now we also have some very high-level guests here. I see Professor Zbigniew Bochniarz and Dr. Nebojša Nešković. So if anybody would like to add something from our guests, you are, of course, most welcome, but you should raise the hand. So if anybody wants to add anything to the discussion, the discussion has actually been very interesting. I think we focused on some really good opportunities, but now going towards the end part of the discussion, I would really like you to think what would be like a summary of what we have been speaking now. So if you would have to give a really short recommendation to the academy, to young people, what should we do in the next years, in the next day, in the next short-term future to really make what we talked about now a reality? Professor Yuri Gogotsi.
Well, one thing is important also to understand, that we need science. We need new materials. Think of many discoveries that really change our life, from semiconductors to lithium-ion batteries, to another one we didn't mention today, but actually very important for energy, white LEDs. Lighting that is much more efficient today compared to incandescent lamps that were used for over a century. Things here. Those are all results of discovering of new materials. Semiconductors, materials for electrochemical energy storage, and organic light-emitting materials, polymer light-emitting materials for OLEDs, which provide us this much cheaper energy consuming lighting. So all the countries should keep finding, supporting science. And for new generations, there are many more discoveries that will enable future technologies, including energy, including green technologies that will either consume less energy or allow us to produce more energy and use it more efficiently. And this is exciting. Making discoveries is great, and dedicating your life to pushing limits of knowledge and trying to bring something useful to the world is important. But also, if you're passionate, if you're a young person, a student, high school student, university student, young engineer, researcher, scientist in any field. Think about what you're passionate about. What is your passion? How you can make the world a better place to be. Because it can only be done by efforts of many, many people. And this is up to the young generation to build this future. So I encourage you not to be passive observers waiting until scientists are working today, like say Professor Zwelber sitting next to me, will solve your problems. You are the one who will need to build the future. So again, start working on it now. Think how you can contribute to a brighter and greener future for the planet. This is where you're going to live, and this is where your children are going to live here. Don't think about relocating to Mars, whatever Elon Musk tells you. And I'm going to stop here and let other people to do the summary.
Yeah, thank you. Really, I mean, it's really important to keep the passion and to do something that is for a higher good, and also to do the hard work. And if you have your passion, then it's easier to do the hard work, and then the results are so much better. And yes, we have also now. Maybe we move to the Zoom. So Professor Alexander Nominet.
Yeah, thanks. I think if we come back to the question of the green policy, there are some real subjects of hope. Our young people, young generation is very committed to that, and this is great. But there is also some points of concerns, which is that now the industry becomes sometimes less attractive. So when I teach, for example, I usually essentially teach in engineering degrees to physicists and chemists. But I have a bit of teaching to the policymakers at the Institute Polytechnique of Paris. And I always tell them, to these future decision makers and policymakers, you always have to assess your decisions on the CO2 efficiency or the environment efficiency versus the public environment. Because we should be very careful with that. I mean, the percentage of people who are convinced of the necessity to mitigate the climate change is unfortunately not increasing as fast as we would like to, and is perhaps in some countries even decreasing. And we will not manage without the support of the population. So we need to find first what reduces as much as possible the CO2 with the least, I would say, annoyance, while it's called more politically correctly social acceptance. And that's very important. And let me just give an example for that. This is what I give to my engineer students. Some of them have lose their vocation. They say, "Oh, I'm working now in the material science, but materials industry is dirty, etc. I don't feel my work is following my values." I tell them, look, the steel is today 8%. The steel production is responsible for 8% of the CO2 emission. Just to compare, the world aircraft transportation is 2%. So every year, the CO2 emitted by steel production is equivalent to 4 years of aircraft transportation. I tell them, look, there's a lot of research projects, there's a lot of challenging in the industry to reduce this. It goes by our behavior to make the circular economy. There are few scientific challenges. There's energy challenges. There's a lot of very, very difficult and exciting scientific challenge to reduce the CO2 footprint of the production of metals. I just gave the example of steel that is valid for aluminum, for every metal. And it's also valid for making new electronics, new batteries, new solar cells, which uses materials that are less polluting. So there's a huge amount of scientific challenge. And if you really want to have impact to reduce the CO2, this is the place to go. We still need policymakers, we still need activists, we still need associations, but we need, I'm sorry, maybe it's productive, but we still much more engineers that will find a real solution and to reduce this emission of CO2 in a sustainable manner, and that will not create more conflictuality, as I mentioned before.
Nice points and important topics. And also, I should add, Professor Nomine is a bit modest. He actually started a Erasmus Mundus Green Nano program, where students are actually learning nanotechnologies and green technologies and how to put them together. And we have just had them in Ljubljana for a semester. And this program, I really have to congratulate you and the team, because the students, when they come, okay, they were so-so, but after the end of the semester, they improved very much. All of them, even those that are not at the high level, each of them showed a tangible improvement, and now they are doing their master thesis. And this is actually the way forward, so that you bring young people, teach them, and also show them the way, so they clarify their values and their mission and their vision, and they know what.
Not only this, they also they are the tool to facilitate the green transition.
Exactly.
Because they're learning these methods for the green transition.
Exactly. So you see, this is what we need to do. More of that, get students into topics that are practical and that can do something, and that's really a way forward that I see. But now we should move back to Professor Eva Kovacevic, who also has some great final recommendations.
What to say now, but everybody also touched all the fields. I have to come back to the processes. We need materials, we need critical materials, we need energy, but also we need processes and institutions and research that are green themselves. So this is one thing. Then more generally, science is a universal language that humanity shares. From the dawn of the humanity, we ask what it is and why it is, and try to find solution. And this curiosity has to remain there by younger generation, by teaching the scientific methods, and also to the awareness of ethical aspects of our research, because there are ethical aspects in every part of what we do. And this should be also one thing that stays very important also for the future. And in the world that faces all these climate changes, research pressure, geopolitical tensions, everything that my colleagues already mentioned, what stays at the end is stability and trust, and scientific cooperation can become a powerful instrument to regain stability, to regain the trust. So this is at least my little bit optimistic hope that especially if we need green innovation in energy, it's not only fundamental science, but there are technical solutions, and it should be possible by creating more opportunities for collaboration across any border. So we should reconnect, we should connect, and yeah, I hope for the better future.
Thank you very much. It's really important that we are optimistic and that we use science for the best. And now we look forward to Professor Uros Weber, the final thoughts.
Thank you. I think my message to global leaders is actually very simple. People do think that, by AI, the science will disappear, scientists are not needed. But my message is actually fund science in order to discover and deploy. And I think that we should make a green technology as a pillar of peace policy, because actually it leads to abundance. And when we have abundance, abundance reduces the tension as well as wars. Living in abundance, no one wants to give up. And I think this message is very clear. Yes. We need science, and we need to put the green technology as one of our pillars of green policy, leading to humanity's advance and literally abundance,
Thank you. This is really such an important topic. If there is no science, there is no progress. We remember end of 19th century, people said science is over, everything has been invented. Scientists will just measure natural constants to more and more digits. And then came quantum physics and relativity and the computer revolution, the electronic revolution. And without that, of course, we would be living like in the middle of previous century technology today, which means that, yes, science is important. We need to develop it. And hopefully now what you have listened here is we convince you that with the further development of science, we can not only clean our environment, but we can also make energy cheap and clean. And in this way, turn poverty into abundance and prevent those rogue regimes from using the proceeds from fossil fuels to fund war, which means that we can move, not in one day, not in 1 year, but in the very near future to the world where there is abundance and when there is peace. And if I may get the PowerPoint back, we are just going to finish up with the thanks to everybody who contributed to the success of this round table. First, this is Alma Mater Europaea University. Its leadership by Professor Ludwig Toplak. Then there is World Academy of Art and Science with the president Gary Jacobs, who is now in Baku at another important international forum. Then European Academy of Sciences and Arts with its professor Klaus Mainzer, president. And the Earth Humanity Coalition, where our representative is Dr. Nebojša Nešković, who also initiated the global decade of science for sustainable development under aegis of UNESCO and the Earth Humanity Coalition. And then, of course, many thanks to the technical team. So here from Alma Mater, I think it was Marko, Miha, Daniel, Luca, Tanya, probably some other people. If I forgot some, add them. And then also in India, we have our great technical team of the World Academy. Harini is with us, Vasugi and Janani did a lot of work, also all other colleagues. So I would really like to thank everybody and thank you for being here with us. Thank you for joining us on this path to prosperity of the development of science, where the environment is clean, poverty is replaced by abundance, and war stops. Thank you. Join us on this journey and see you soon.